Let's go over a few problems for this week's discussion quiz. For 1, we'd like to solve this limit, the limit as x approaches -2 of x plus 3 divided by 10 minus x cubed. If we can use direct substitution because this is a rational function, then we can just put -2 in place of all of the x's. Let's try that out. This is equal to -2 plus 3 divided by 10 minus -2 cubed. I think this is going to work out. We're not going to divide by 0, which would be the only problem for this function, so it looks like direct substitution works. This means if we look at the numerator, -2 plus 3 is a positive 1. This is 10 minus, if you cube -2, that's going to be -8. So this is 1 over 10 plus 8, or 1 over 18. So this is the solution for the first limit. So going back, I'd like to just note here that the step we did was direct substitution. In that we had a rational function, -2 was in its domain, so we could simply plug it in to get our value. Let's consider the limit as x approaches 4 of the rational function x squared minus 4x divided by x squared plus x minus 20. If you try direct substitution this time and you put a 4 in place of all the x's, you'll have 0 divided by 0, which is undefined. For this reason, direct substitution is not going to work. So what we can do, though, is in this limit, as we approach 4, perhaps we can factor both the numerator and the denominator and cancel a common factor, so we can solve this limit. In the numerator of this rational function, we have x squared minus 4x. I see I can factor an x out from both terms. And when we do, we're left with x minus 4. In the denominator, I have x squared plus x minus 20. I think we can factor this into two linear pieces, where we have an x and an x. Because this last number is negative and this is positive, I know we have to have a plus and a minus. I want two numbers that multiply to -20, yet add to a positive 1. Those will be 5 and 4. Before moving on, direct substitution did not work because when you put 4 in place of all the x's, you get 0 divided by 0. I was expecting there to be an x minus 4 that I could factor out in both the numerator and denominator. Notice that this 4 put in place of those two x's creates a 0 over 0. That being said, in this step, I'm now going to cancel this and this. In a limit, as x approaches 4, this is still equal to, I'll just write the x in the top and x plus 5 in the bottom. Note that you don't have to include the parentheses since we have a single term if you don't want to. The reason that this is equal to this is because limits are defined for everything except x is equal to 4, so this expression is in fact equal to this one. Now down here we have a new rational function, and by direct substitution you can put 4 in place of all the x's. That is, since 4 is in the domain of x divided by x plus 5, we have 4 over 4 plus 5. When you simplify this, this is 4/9, and this is the answer for question 2. For this last limit, again, we have a rational function. Can we simply put 2 in place of x to get the answer by direct substitution? The answer is no. If you put 2 into the numerator, you get 2 cubed, which is 8, minus 8, that's 0. That's not a problem, but in the denominator, if you put 2 in place of x, you get 4 minus 4, which is also 0. So direct substitution does not work. The goal for this problem is the same as the last one. Can you somehow factor this expression and cancel a common factor? Keep in mind that because we're approaching positive 2, you should be able to have a x minus 2 that factors out of the top and bottom. And the reason for this is, if you put 2 in place of the x's, it gives you 0 over 0. What we have to figure out is, well, how do you factor x squared minus 4? And x cubed minus 8, so there's an x minus 2. I think one of those is easier. If you look at the denominator, we have x squared minus 4, and if we factor out an x minus 2, we just have to know what goes over here to multiply back to this. that is going to be x plus 2. When you have a difference of two squares, it can be written like this. Notice x times x is x squared. Negative 2 times positive 2 is negative 4. And if you look at the two middle terms, they're equal and opposite, so they cancel. What is probably not as obvious is, well, is there a similar method for taking and factoring a difference of two cubes? I'm going to write down a formula for this. What if you have a cubed minus b cubed? Is there a nice way to factor this? It turns out there is. This is equal to a minus b, and then what is left over is a squared plus ab plus b squared. You can use this formula in factoring a difference of two cubes. Here the a and the b are x and 2, so you can put that in place of all of the a's and b's in this expression. So this will be x minus 2, which we already have. And over here we'll have x squared plus 2x plus 2 squared, which is 4. I'm going to place that here. So this is x squared plus 2x plus 2 squared again, which is 4. So this is equal to this. I now have a common factor of x minus 2 that we can cancel. This cancels with that. And this is equal to the limit as x approaches 2 of. In the numerator, I'll just put, without parentheses, x squared plus 2x plus 4. You can include the parentheses if you'd like. In the denominator, we have x plus 2. Again, you do not need the parentheses with a single term. This rational function is defined at 2, so by direct substitution, you can simply put a 2 in place of all the x's. That is, this is 2 squared plus 2 times 2 plus 4, all over 2 plus 2. And when you simplify that, okay, 2 squared is 4, 2 times 2 is 4. We got another 4 at the very end. In the denominator, we have 2 plus 2, which is also 4. Okay, so that's 12 over 4, and when you simplify this, you get a value of 3. 3 is the value of this limit here. So that's it for the practice problems. If you're curious as to why this is true, just to go through an explanation of why a difference of two cubes is equal to this expression, you can take this side of the identity, distribute in a, distribute in this negative b, and see if it simplifies to a cubed minus b cubed. I'm going to take a second to do that. So if you first start by multiplying an a into the parentheses, you'll have a cubed, a squared b, and ab squared. I'm going to write out those three terms. So that's a cubed plus a squared b plus ab squared. Below this, I'm going to write out what you get if you multiply in a negative b. We'll have negative a squared b, negative ab squared, and then negative b cubed. So that first one was negative a squared b. I'll put that here. The second one was negative ab squared, and the last one is negative b cubed. The reason this works is, if you look at the expression, this cancels with that, this cancels with this, and what you're left with is a cubed minus b cubed. So it's easy to verify that this is in fact a true statement by multiplying it out. So I just wanted to go over that in case you had not seen this expression before.